Touchdown confirmed, Perseverance safely on the surface of Mars, ready to begin its mission of seeking signs of past life. Right now, researchers are piecing together a discovery that could completely rewrite everything we thought we knew about the red planet. After decades of questions, NASA's InSight lander has finally given us a rare glimpse into the very heart of Mars, and what it found is nothing short of mind-blowing. For years, scientists believed that Mars had a core structure similar to Earth's, a solid inner core surrounded by a molten outer core. This seemed logical. After all, Earth and Mars both formed from the same primordial materials. If Earth developed a solid core, why wouldn't Mars have one too? But here's the twist: the discovery NASA just made has shattered this assumption. Mars's core isn't solid at all. In fact, it's completely liquid. This revelation forces us to rethink the entire history of the planet. Not only does it challenge our understanding of Mars's geological evolution, but it also raises big questions about the planet's ability, or rather, its inability, to sustain life. But that's not all. This discovery could hold the key to understanding why Mars lost its atmosphere, why its magnetic field faded, and why it turned into the frozen desert we see today. Could it even tell us something shocking about the future of Earth? Let's dive deeper into this groundbreaking discovery. A shocking revelation: Mars's core isn't what we thought for decades. Scientists assumed Mars's core was similar to Earth's. Earth has two main layers in its core, a solid inner core of iron and nickel, and a molten outer core that drives the planet's magnetic field. We also thought Mars had a similar structure, only on a smaller scale due to its smaller size. Many believed Mars once had a magnetic field, a thick atmosphere, and liquid water, conditions that might have supported life in its distant past. But NASA's InSight lander has completely upended that idea. Mars's core is not solid. It's entirely liquid. This unexpected discovery has forced scientists to re-examine everything they thought they knew about Mars's interior, its geological activity, and its potential to sustain life. If Mars had a solid core, the seismic waves from Marsquakes would have behaved in a predictable way, reflecting off the core mantle boundary as they do on Earth. But this wasn't the case. The seismic waves traveling through Mars's interior acted as if the core was entirely molten. This was a huge surprise. Unlike Earth's core, which has both a solid inner core and a molten outer core, Mars's core contains a mixture of lighter elements like sulfur, oxygen, and carbon, preventing it from solidifying the way Earth's core did. This means that Mars never developed the strong, protective magnetic field that Earth has today. Without this shield, Mars's atmosphere was slowly stripped away by solar winds, eventually transforming the planet into the cold, barren world we see today. How NASA's InSight mission changed everything. In 2018, NASA's InSight lander touched down on Mars with a singular mission: to listen for Marsquakes and map the interior of the planet. Scientists wanted to study the planet's structure in the same way that earthquakes on Earth reveal details about our own planet's inner workings. Through seismic data, scientists hoped to answer a fundamental question: what lies beneath the surface of Mars? But the results were unexpected. Marsquakes revealed something that no one had anticipated: the core of Mars is not solid, it's liquid, with a composition that's very different from Earth's. The seismic waves passing through Mars's interior showed no signs of bouncing off a solid core. Instead, they passed through the core as though it were entirely liquid. This was clear evidence that Mars has no solid inner core. What makes Mars's core so unique? So, why does Mars's core remain liquid, while Earth's core solidified over time? The answer lies in a few key factors: the composition of Mars's core, its size, and how fast it cooled. 1. A core made of light elements. One of the biggest differences between Earth and Mars is the composition of their cores. Earth's core is mainly composed of iron and nickel, making it very dense. Mars's core, on the other hand, contains a higher percentage of lighter elements like sulfur, oxygen, carbon, and hydrogen. These lighter elements lower the melting point of metals, which means Mars's core has stayed molten at much lower temperatures than Earth's. 2. Mars's small size. Another crucial factor is Mars's size. Mars is only about 1/10 the mass of Earth, meaning it has far less material pressing down on its core. Without the extreme pressures that Earth's core experiences, Mars's core never reached the necessary conditions to solidify. Earth's larger size allowed the immense weight of its outer layers to compress its core to a solid state, even under high temperatures. Mars, however, is too small to generate these pressures, meaning its core stayed liquid from the start. 3. Rapid cooling. Mars also cooled much faster than Earth. When a planet first forms, it retains heat from the collisions that built it, from radioactive decay, and from the pressure of its own formation. Larger planets, like Earth, can trap this heat for billions of years, keeping their cores active. But Mars, being smaller, lost its internal heat more quickly, preventing convection in the outer core, which is necessary for sustaining a magnetic field. Without this magnetic shield, the planet was left vulnerable to solar wind, which gradually stripped away its atmosphere. The consequences for habitability, why Mars became lifeless. This discovery changes everything we thought we knew about Mars's ability to support life. Without a solid inner core, Mars was never able to maintain a stable magnetic field. And without a magnetic field, Mars couldn't protect its atmosphere from being blasted away by solar wind. The planet slowly lost its atmosphere, which caused its climate to collapse. Mars once had liquid water on its surface, but as the atmosphere thinned, the planet's climate became frigid, eventually freezing any remaining surface water. Today, Mars is a cold, barren desert. The loss of its magnetic field and atmosphere sealed its fate as a lifeless world. What if Earth followed the same path? What if Earth's core had never solidified? If Earth's core were entirely liquid, the consequences would be catastrophic. Without a solid inner core, Earth would lose its magnetic field. Without that protection, the solar winds and cosmic radiation would bombard the atmosphere, slowly stripping it away. Oxygen levels would plummet, and water would evaporate into space, turning Earth into a lifeless, uninhabitable wasteland. The planet's rotation would also become erratic, causing extreme shifts in climate and weather. Earth would become geologically unstable, with more frequent earthquakes and volcanic activity. In short, if Earth had followed the same path as Mars, life as we know it would not exist. The planet would be unrecognizable, and we wouldn't be here to witness it. What this means for the search for life beyond Earth. Mars's fate is a stark reminder that habitability isn't just about being in the right place in the galaxy. A planet's core composition plays a crucial role in whether it can sustain life. As scientists search for exoplanets that might support life, they need to consider more than just a planet's distance from its star. The planet's core, how it's structured and whether it can maintain a magnetic field, might be just as important as its location in the habitable zone. Exoplanets with liquid cores could face the same fate as Mars, losing their atmospheres, and becoming inhospitable. But not all liquid core planets are doomed. Some massive exoplanets may still generate magnetic fields through rapid rotation or unique internal processes. Scientists are now studying how planets larger than Earth, called super-Earths, might behave differently, with the possibility of partially solidified cores that could create stable magnetic fields. The lessons from Mars tell us that a planet's ability to maintain a stable atmosphere is largely determined by its magnetic field. If a planet loses that magnetic protection, it can lose its atmosphere and its ability to support life. Understanding this is crucial as we search for life beyond Earth. Mars may have once been a warm, wet world with the potential to support life. But it lost its atmosphere, its magnetic field, and its ability to sustain life because of its unique core structure. Earth, however, is lucky to have a solid inner core that helps protect our planet from the harsh environment of space. Let's